Pod fundamentals. Kubernetes pods are the smallest deployable unit, or you can say the compute unit that you can play in Kubernetes. A pod could be a single container and could be multi-container. And later on, I'll give a little bit more detail about difference between a container pod and what is a container runtime. And you can host multiple containers and they will share the same resource. The shared resource could be your networking, storage, ephemeral storage that you will launch during the pod. What are ephemeral storage? Anytime you create a pod, when you're deleting the pod or the pod is getting destroyed, that storage goes away. It is pretty much the root file system of the container itself. Communication, when you interact with the pod, containers in the same pod, they use localhost. So pretty much they are as if they are running on the same node. And life cycle of the pod is pretty well defined: pending, running, succeeded, and failed. So here is a simple example of illustrating how a pod and containers are different in a way that pod is a higher level abstraction of the container. So in the left example, you can see a pod is containing only one container, and the deployment definition is pretty straightforward. It says specification, container name, and the image. And if you add more container to it, you can simply keep adding the containers in the spec section, like a list in YAML file. And in this example, I'm deploying an Nginx container and a BusyBox. And now, second thing begs the question before we actually start doing the lab. So why they have created difference? And you can see a lot of confusion term between Docker and container, and pretty much across the industry it has become synonym. But what they did, they forked their repository and open sourced and donated the container daemon to the open source community. What it allowed Docker and the whole community to take the container D and build their own application on top of that. So it means you don't need to actually install Docker in order to use container technology, even though they are very synonymical. And Docker went on being a developer tool which allows you to do a lot of development. So example, for a Kubernetes environment, you do not need to install Docker. You can simply install a container D, which is a container runtime, and that will be more than enough to manage it. Remember one thing, Kubernetes is a container orchestration platform. It is not a Docker orchestration platform. Docker itself is a container orchestration platform, but with a different design goals. Kubernetes by default, it supports bunch of runtimes. Number one being the containerd, and which is a widely available. And there are other container runtime environment like CRI-O and Docker engine. You can actually have it full blown Docker as well. And also Mirantis container. So let's start some of the hands-on lab example. To see the repository of the Kubernetes tutorials, you can go to this file. I'll post the link below. In this one, there are simple steps to actually copy and paste and just play around with your environment. If you do not have a Kubernetes cluster set up already, you should check out other videos where I have mentioned how to set up a local Kubernetes cluster using Docker Desktop. Link will be pasted below. And in this example, what I'm going to do is I will assume that you have kubectl set up and the cluster is running. So how do I do that? First thing, I go to my command prompt. I just do a kubectl get node. You can see I'm running a Docker Desktop. There is only single node, which is a control plane as well as the worker node. And if I want to deploy a container, I can simply do a kubectl run and giving the name of the container. You can give any name, specifying the image and the port which will be exposing later on, and telling restart never. It means if it dies, do not restart it. In many cases, if you want to make it restart, that is mostly in case of application you want to make it highly available or a self-healing feature. So what I do here, I just copy paste the command and I can see my container has started running. If I want to get more detail about the container, I can simply do a describe on the same. PO and pod are the same, and you can see it gives me more information about the container lifecycle. And the most interesting part what I want to highlight here is this, which is the events. Later on, when you start working on Kubernetes, you will realize this event is so critical in troubleshooting to find out what exactly went wrong. In this case, because there was no issue, so it actually successfully was able to do anything. But in later on many cases where we have labs where we are troubleshooting a restarting container, you'll see how this becomes very important. And rest information is metadata about the container. It tells what it's doing. And I can use the same method to do a logs as well. I can do a kubectl logs and it will show me all std out logs here. Because this is an Nginx container, it's showing a web log. And now the container has been deployed. How do I access it? In order to access it, you have to deploy something called service. For make it a very simplistic understanding, you can think of a one way of port forwarding that particular resource to outside world. This concept has been detailedly explained in the service chapter that you can take a look. So I go here and I simply deploy my service. And you can see service what I'm telling kubectl expose to the pod. This is my pod which I just deployed. Type is a node port. There are a bunch of different types of service, and the port mapping I'm telling port 80 to port 80 forward. So if you don't understand what is port forwarding, you might have to read a little bit on the networking concept. And now my service has been deployed and I can check it by doing this. So I see my service has been deployed, and this is the source, and this is the port which is exposed on the local machine. So if I want to see my Nginx running, I can simply go localhost and you can see my service is running. And if you want to do a little bit more, you can see here one request came. I can do a -f option, which is basically continuously checking, and if I refresh this one, see, I got another request. So it tells me from where I'm getting the request. Now next thing I'm going to touch on is the multi-container. So right now what we did, we deployed a one pod which has only one container. In the next example, I will deploy a pod which has multiple containers. In this case, I'll be using this YAML file because it has more definition. I go here and type m.yaml, and this explains the kind, metadata, and I'm putting all the containers here. I have more detailed explanation about this concept later on. I do kubectl apply. You can see the container is up and running inside any of the container. Example, because I have more than one container, if you want to see the log of a particular container, then you need to use a -c command. I need to change the container name. So you can see the first container being the Nginx, it is showing the log. If I change it to second, you won't see any log because it is a busy box container, it's doing nothing. So that explains the basic mechanism how a multi-container pod you can illustrate and how you can see the service of it. In next